As theorizing turns from associationist behaviorist explanations to information processing based representational explanations, memory starts to rise to the forefront. So let's start in talking about memory as it emerges in cognitive science by giving a general definition of memory. Memory encodes, stores, and retrieves information to influence future actions. So people like Miller here develop and elaborate a view of memory as representations. So Miller was the author of this famous paper, the magic number 7 plus or minus 2. This view of memory as representations that are stored in specific brain areas eventually becomes what I'll present as the modal model of memory. As a result, cognitive science and cognitive psychology texts, especially early on, tend to have chapters on memory and no chapters on learning. However, along the way, cognitive scientists have come to characterize memory as involving processes, representations, and containers. So ultimately, cognitive science has gone from an exclusive representational container notion of memory to a memory that integrates the reconstructive process in the representational container view. In general, memory is now characterized in terms of the processes and structures involved in encoding, consolidating, that is retaining, storing, retrieving, and using information. I'm going to structure the lecture using the modal memory model. Thus, we'll start the lecture with memory systems that encode information by the activation patterns of their neurons. These systems have relatively short information half-lives and usually require some form of updating in order to retain information over any longer period of time. These memory systems generally operate in a manner that's largely dissociated from learning, and the temporal limitations of these systems render them of limited usefulness in cognition. They are very much in the moment kinds of memory. Thus, longer-term memory systems have evolved to handle encoding information for future use that goes beyond that information in the moment. Unlike these shorter-term memories, longer-term memory systems specialize in encoding information by altering the structure and/or the functioning of the brain. Thus, we'll look at various cellular mechanisms that serve longer-term memory systems before looking at those systems in our second memory lecture. So turning now to this second part of our memory lecture, we're going to start looking at memory systems using this modal model as our cue. So we'll begin talking about the modal model. Then we'll turn our attention to the first component of the modal model, sensory memory. We'll talk about sensory memory generally, and then we'll talk specifically about iconic and echoic sensory memories. Finally, we'll finish the lecture by talking about the working memory system. We'll talk about the phonological loop, the visual spatial sketchpad, and the central executive. Now, historians generally credit Richard Atkinson and the guy who's pictured here, Richard Schifrin, with the first statement of the contemporary model of memory, the modal model of memory. And they usually pin it at their 1968 paper, Human Memory, a Proposed System and Its Control Processes. Though the paper offers an explanation of operant conditioning which proves false, the paper is notable for two things. First, it gets the containers or structures right at a gross level. And second, it recognizes that memory needs control processes, paving the way for the contemporary modal model. There are a number of misconceptions that are associated with this paper. First of all, by pointing to the 1968 paper, they really sort of misdate when this switch to the modal model of memory occurs. Atkinson and Schifrin were theorizing about this model as early as 1965. In addition to that, people often portray the short-term memory component of the Atkinson-Schifrin model as being overly simplistic and inadequate in various ways. And hence, they talk about the development of the concept of working memory as a radical change in the basic structure of the model. So, for instance, Bailey and Hitch have questioned the specific structure of the short-term memory store and proposed that it's divided into multiple components, and criticized Atkinson and Shiffrin for not recognizing this. Now, there wasn't as much data, but it's also actually incorrect. They do divide up the modal short-term memory store in that 68 paper. Motter has been further criticized by suggesting that rehearsal is the key process which initiates and facilitates transfer of information to long-term memory. This criticism is somewhat unfounded as well, because Atkinson and Shiffrin pretty clearly state that there's a difference between rehearsal and coding. And coding is much more akin to an elaborative process and much more amenable to the contemporary understanding of how memory in working memory gets consolidated into long-term memory. They do, though, offer up a fuzzy sets explanation of operant conditioning, which is genuinely incorrect. And their model in general is highly mathematical, so there's some basis for why people might misunderstand and misconstrue it. For aficionados of historical accuracy, here's their actual model as it dates back to 1965. Here we see these sensory memories in the sensory registers. Attention feeds those into the short-term store. The short-term store is maintained through rehearsal in a rehearsal buffer. There are sensory-specific registers, auditory, verbal, linguistic registers. There's encoding into long-term memory and retrieval from long-term memory. So returning to the general format of the model, let's see how each element looks now. We'll start with the sensory memory component, and then we'll move slowly but surely to the working memory component, and then in the next lecture to the long-term memory component. In each element of the contemporary theory, we find a representational element and control processes that work to manage the information in the store, as well as facilitate information transfer between stores. And we'll pick this up in the next lecture module.